Understanding electrostatics. Matter is composed of neutral atoms. The electrical neutrality of the atoms is due to the fact that the positive charge of the nucleus of the atoms is compensated by the negative charge of the electrons that surround it. The outermost electron may either be only loosely connected to the rest of the atom or may be more firmly embedded in it. Atoms of the first type tend to part with electrons to adjacent atoms, while those with the second type tend to tear electrons away from adjacent atoms. It is because of this phenomenon that, for example, glass becomes positively charged when it is rubbed with a silk cloth, whereas ebonite acquires a negative charge on being rubbed with a woolen cloth. If two small balls suspended pendulum-wise are given electric charges of the same sign, if by touching them they will be pushed some distance apart by mutually repellent forces exerted by the two similarly charged balls. On the other hand, two oppositely charged balls will attract each other, and when they come into contact, their charges will neutralize each other. A positive charge means that there is a deficiency of electrons. A negative charge means that there is a surplus of electrons in relation to the neutral condition of the atoms. Electrons are the elementary particles of electricity. Each electron has a charge, a rest mass, and a radius. Since similar charges repel each other, the electrons so arrange themselves at the surface of an electrical conductor that the space inside it contains no charge and is thus entirely free from electrical forces. When a charged conductor is brought near an uncharged, a neutral one, a separation of charges is induced on the latter. If the first conductor has a positive charge, then the initially neutral conductor will become negatively charged on the side facing the positive conductor, while on the other side will acquire a positive charge of the same magnitude. This positive charge can be discharged to the earth, and the second, initially neutral conductor will then remain negatively charged. This method of charging is known as electrostatic induction. The repulsion of similar charges may produce repellent forces of considerable magnitude at pointed extremities, where the electrons become concentrated and are actually discharged from the conductor, so that they can, as it were, be sprayed to a neutral conductor, which in turn will acquire a charge of the same sign, in this case negative, as that of the first conductor. The Van de Graaff generator makes use of the possibility of spraying an electric charge from sharp points of a conductor. The charge is thus applied to a belt conveyor made of insulating material which conveys the charge into the interior of a spherical conductor of a large radius, where the charge is collected by a comb of pointed electrodes. More and more electricity is collected in this way from the traveling belt and is accumulated at the surface of the large sphere, which thus acquires a very high charge. The power output from the electrostatic generator is not very large, for the charge accumulated by this method cannot sustain a current of any significant magnitude. On the other hand, very high voltages can be obtained, of the order of some millions of volts. The voltage can be further increased by installing the generator in an enclosed space in which the air pressure is increased above the normal atmospheric pressure, so that the spark over voltage to earth components is increased. The amount of electric charge that can be stored up in a body is called the capacity of that body. A condenser or capacitor is a device specifically intended to store up an electrical charge. Its capacity is determined mainly by the action of the electrostatic induction. It consists essentially of two conducting surfaces, plates, which are insulated from each other. In this case of a variable condenser, the area F of these surfaces and/or the distance apart can be varied. Obviously, the quantity of the electricity that can be stored up by induction will be greater according as F is larger and the gap D between the condenser plates is smaller. The capacity of a plate condenser is therefore proportional to F and inversely proportional to D. High capacity condensers are composed of plates consisting of rolled up thin metal foils separated by sheets of paper as insulating medium. The capacity of a condenser may be compared with the cubic capacity of a tank, which depends on the area of the bottom and on the height. If a small ball pendulum is attached to a conductor and the latter is charged with electricity, the pendulum will acquire a deflection due to electrical repulsion, which is proportional to the magnitude of the charge. There is an analogy with the pressure of the water in a tank, which pressure can be measured by means of a mercury manometer. The pressure of the water corresponds to the electric potential or voltage, the unit of measurement being the volt. The voltage is associated with the electric charge and the capacity C of a conductor by the following relation. In the space which surrounds an electrically charged body, an electric potential occurs, which is proportional to the charge Q and inversely proportional to the distance r from the center of the body. The electrical condition produced in a space by the presence of electrically charged bodies is called an electric field. Points which all have the same potential voltage are located on equal potential surfaces. Forces always act in the direction of potential gradient. The electric force which is exerted upon a charge of unit magnitude in an electric field is called the field strength or field intensity. It is always directed perpendicularly to the equal potential surfaces. The lines of forces in an electric field represent the direction of the force at any point on their length. The properties of an electric field can be described in terms of equal point surfaces and lines of force. The lines of force are conceived as emerging from positive charges and dissipating